So question number 2 from the 2021 free response section, part A and B. So it says here the particle P is moving along the x-axis with a velocity given by this function, v of t is equal to sine t to the power 1.5, and it gives us a position of t equals 0, x equals 5. Second particle is given by this equation here, so it's a t minus 1.8 times 1.25 to the power t, and the position is given as 0 and 10. Okay, at time equals 0, the position is 10. So the first thing we have to recognize is that we are talking about, we're given functions for velocity, and we are being asked about the position. So we need to then use the fundamental theorem of calculus. So we need to then relate the integral to the position of that particle. So here I have the equation that is going to represent the position x for particle P. So to do that, we need to make sure that we first of all, I'm going to highlight this, that we connect this idea that at t equals 0 we have a position of 5. Okay, so we need some starting point, and the integral is going to represent the displacement from that starting point. Okay, so here's our expression that will calculate the position of that function, and the same thing here for the Q particle. We need to again connect the starting point of 0, 10 in the integral, so we have a starting point of 10, and the integral represents the displacement from the position of positive 10. Okay, so here I've also drawn the graphs. So to find the integral of these, we're going to need the area. So we're going to calculate the area underneath the curve to be able to figure out the displacement. So I'm going to rewrite this expression. So we need to find the position of P at x equals 1. That's going to be given by this integral from 0 to 1. And there's that point. So what I do then is I'm going to shade that area. I'm going to find this area from my graphing calculator, and that area is going to represent the displacement. So when I calculate that area, I get an area value of 0. Let me make sure that's positive 3707. Okay, so this represents 0.3707. Okay, and that's, in this case, it looks like it's in meters. So then our area, we add the area to the initial position. So we start at 5. Our displacement is positive. Our displacement is positive 0.3707. So the position of particle P at t equals 1 is going to be 5.3707. Okay, so then that represents the position of particle P. We do the same thing for particle Q. So in this case, here's my graph for particle Q. I want to use the area under that graph as the displacement. So I'm going to find the position of particle Q at t equals 1, and that's going to be found by the starting position of 10 plus the area under the integral from that starting time of 0 to 1 of x minus 1.8. Okay, the area under that curve then, when I need to go to my graphing calculator for this. And when I calculate this area under this curve, that's going to represent the displacement of the Q. And from my calculator, I get a value of negative 1.4356. Okay, so I'm going to subtract that displacement from the position. Okay, so finishing that off here then, that is going to be equal to a starting position of 10, and I'm going to go backwards, and my velocity is in the negative, so we know that's going backwards, which then calculates a negative displacement. Here, velocity is positive. It's above the x-axis, so that my displacement is positive. So when I work that out, I end up with 8.5644 when it's rounded. Okay, so the position of particle Q at t equals 1 is represented by that. Okay, so part B of this says, are the particles P and Q moving towards each other or away from each other at time equals 1? Well, since the velocity of x is in the positive direction, okay, we are at 5, and I'm just going to draw this out. So we are at this point here at 5 point something, 5.3, and this particle P is moving in the positive direction. We can see that the value of the velocity is positive here. In fact, if we calculate the value of the velocity coordinate here is positive 0.8415. So we know that we're moving in this direction for P. Okay. For Q, we are somewhere over here at 8.6, somewhere around there. Okay, I'm just gonna round that to 5.4. Now this is the velocity here. If we look at the velocity graph, the velocity value here is going to be -1. Okay, so if you actually calculate the velocity, now you don't necessarily need to calculate the velocity values. We can see that the velocity is negative here and positive here. Really, that's really the most important part. So they are at this point, and they are traveling, Q is traveling in the negative direction. It's going this way. Okay, so we can see that. Are they moving towards each other or away from each other at t equals 1? Well, they are definitely moving towards each other, and we can see that when we draw this out. Okay, so we know that the velocities are in opposite directions, and so we know that they're either moving both this way, they're towards each other, or they could be moving in this direction. So we just need to make sure the relative positioning to determine whether they're closing that distance or increasing that distance. And a picture would be probably the easiest way to demonstrate that.